In this video, we are going to learn how to solve quadratic inequalities. So we're going to solve each inequality algebraically. So what we have to do first is we're going to factor this quadratic on the left side of the inequality symbol. So they have a 2 and an x in common in both terms. So we'll factor out 2x, and we'll be left with x minus 7. Now I have two factors being multiplied that are less than 0, meaning it's a negative number. So there's two things that can be going on here. We could have 2x be a positive number and x minus 7 be a negative number. In this way, we would get a positive times a negative, which would give me a negative overall. Or 2x could be a negative number where it's less than 0. And x minus 7 will be a positive number. So this way a negative times a positive is a negative. Now we can solve both of these equations. So we'll start with the one on the left. We'll get x is greater than 0 and x is less than 7. Or on the right, we'll have x is less than 0 and x is greater than 7. Now on the right, this one is impossible. There's no number that can be both less than 0 and greater than 7. So our work there will just stop for the moment. Now on the left, what numbers are greater than 0 and less than 7? Everything between 0 and 7. So the solution to the inequality would be 0 is less than x, which is less than 7, which is another way to write that compound inequality just above it. The one on the right would yield no solution, so we're not going to use that solution. Now let's look at the same quadratic inequality, but now with it being greater than 0. So again, we start by factoring. So we'll get 2x times x minus 7 is greater than 0. But now instead of them being opposite in sign, they're going to have to be the same sign so that they're a positive number rather than a negative one. So either they are both positive, meaning 2x is greater than 0, and x minus 7 is greater than 0. Or 2x is less than 0, meaning negative, and x minus 7 is less than 0, which means that factor is also negative. Because a negative times a negative would be a positive number as well. So we'll solve both of these, giving me x is greater than 0 and x is greater than 7. Or we'll have x is less than 0 and x is less than 7. So interpreting these, I have x is greater than 0 and greater than 7. So I have to be very careful because 2 is greater than 0 but is not also greater than 7. So I want this inequality just amounts to x is greater than 7, just so it can be true for both inequalities, because truly anything greater than 7 would also be greater than 0. Or the other one, we have x is less than 0 and x is less than 7. So if I were to if you use 5 would be less than 7, but it wouldn't be less than 0. So this just amounts to x is less than 0, because again, anything that's less than 0 would also be less than 7, but not everything that's less than 7 is less than 0. So in total, our answer would be x is greater than 7 or x is less than 0. That's a compound inequality. Now let's look at this in a different respect, because these are quadratics. We can also use their graph to solve them as well. So let's find the solution sets for each quadratic inequality by using their graph. So I drew the graph of 1/4 x minus 2 squared minus 1. And now let's look at the inequality and the graph and see how they compare. So first we have 1/4 x minus 2 squared minus 1 is greater than 0, which means that we're dealing with a positive number here. So in this case, I want all the spots where this graph is positive in the y, in its y value, which would be everything from here onward. Those are all positive y values, and everything from here onward to the left where it's also positive y values. Everything in between would be below the x-axis, maybe negative values, which wouldn't adhere to the inequality. So if I'm just looking at this, I can see that the solutions are less than 0 or greater than 4. You'll see here I use open circles because I'm not equal to 0, so I shouldn't actually use the values at 0 and 4. Now let's look at the other scenario. What if it was less than 0? Maybe we use everything that's below the x-axis. Then we get everything in between those two numbers rather than outside of them like we saw earlier. That means that the solution set would be 0 is less than x, which is less than 4, meaning all solutions between 0 and 4. So if we know whether our graph opens upward or downward, it can help inform us what the solution will be, and we can just look for zeros for that quadratic function. Because luckily we've been solving quadratic equations up to this point. So let's just use that technique and the fact that it's opening upward or downward to actually solve these inequalities, rather than going through all these if-then statements. So let's look at this top left example. This has a -2 as its a coefficients in front of x squared, so we can tell that it opens downward. So if it opens downward, we can use that visual to help us solve, but let's first figure out where it crosses the x-axis by setting this quadratic equal to 0. So that we know exactly where it would cross the x-axis. So first I can see that I could factor out a -2, giving me x squared plus 4x plus 3. And then I could factor this quadratic, looking for two numbers that multiply to 3 but add to +4, giving me -2 times x plus 3 times x plus 1. And then I can set each of those factors equal to 0, giving me the two solutions, x is equal to -3 and x is equal to -1. So those are the two spots where we cross the x-axis but pointing downward. Now, I want this to be less than 0. So if I'm imagining on a graph that I have a quadratic that's opening downward and crosses the x-axis at -3 and -1, then all the solutions where it's less than 0 would be on the branches to the left here and the branches to the right, but not including those spots where it crosses. So my solution would be x is less than -3, all values to the left of this -3, or x is greater than -1, all the values to the right of the -1. So now I can use that factoring technique and more quickly get to my answer once it's factored. So let's try that again. So here we have x squared minus 3x plus minus 18. It's a positive coefficient in front of x squared, so that opens upward. And if I factor this, I need two numbers that multiply to -18 but add to -3. That would be +3 and -6. And equals 0. So setting both of them equal to 0, I get x is equal to -3 and x is equal to 6 as my two solutions. So if I'm imagining a graph, it crosses at -3 and all the way over at 6, and it opens upward. So all of these solutions that would be less than 0 would happen between -3 and -6, but not including -3 or 6 because it's less than, strictly less than 0. So my solution set would be everything between -3 and 6. And to finish this off, I'm going to show you one more way we can go about solving these inequalities. Now, if you just have one x variable, for example, let's say you completed the square on your quadratic, then we can go about just solving for x. Instead of thinking about its graph, we can treat it like a normal inequality, where we'll subtract 5 from each side. So negative 1/2 times x plus 2 squared is greater than negative 5. And then I can multiply each side of my equation by negative 2. But whenever you multiply by a negative, that inequality in the middle is going to flip. So I'll get x plus 2 squared is now less than positive 10. And then I could take a square root of both sides, giving me the absolute value of x plus 2 is less than the square root of 10. Now, if you remember solving absolute value inequalities, whenever an absolute value is less than a number, it means it was between the positive and negative of that number, which would bring me to negative square root of 10 is less than x plus 2, which is less than square root of 10. And just to show you how it could relate to an OR inequality, if this was greater than the square root of 10, then this would have been an OR, where it was less than negative square root of 10 or greater than square root of 10. But to finish this off, we'll subtract 2 from all parts of the inequality. And I'll get that x is in between negative 2 minus the square root of 10 and negative 2 plus the square root of 10. This is just another way we can go about solving these quadratic inequalities. And that is how you solve a quadratic inequality.